Hello students, welcome to the e-lecture series on pharmaceutical microbiology. In this session we are going to see about aseptic area and microbial control part 2. Hello students, welcome to the session on aseptic area and microbial control. In the last session we have seen about what are aseptic techniques, we have seen about what is an aseptic area, different sources of contamination of aseptic area and methods to prevent the same. So for quick revision, what was an aseptic area? It is an area within a clean area which is specially designed, constructed, serviced and used with the purpose to prevent the microbial and particulate contamination. Okay, so as it requires, as we have seen the definition, it requires special building facilities and requirements for proper aseptic processing of the sterile preparations, right? So in this session, we will see about different facilities and the layout of aseptic area, which will ensure that we will produce complete sterile products. Okay. So what were the sources of contamination? You had 4 different sources of contamination. One is from the atmosphere. Second is from the personnel, that are the operators. Third from the equipment, and fourth which was from the raw materials. Okay. So let's begin with this session in which you will see the layout of the aseptic area and different building production facilities which are required for proper aseptic conditions maintenance, right? So let's begin with the session. This presentation you will see about aseptic area layout, you will see about clean area classification, and you will see about the building construction and the production facilities which are required in an aseptic area. Okay, so why you require different areas in the production facility? Okay, we need an aseptic area which is completely free of microbial and particulate contamination, which you cannot get if you have a normal layout. Okay, and for this purpose the production facility is divided into different areas which will ensure smooth flowing of the production and thus ensuring proper aseptic condition within the sterile manufacturing room. Okay, so basically the production area in the aseptic area layout is divided into following categories. Okay, you have a clean room, you have the different compounding room, you have the aseptic filling room, then you have the quarantine room, and finally you have the packaging and labeling area. Okay, so we'll see each area in detail and what are different functions and the facilities of different areas, right? As you must be seeing in your lab. Okay, just for the simple example, in your lab you have the different stock room. Okay, different area is there which from where you can get your raw materials. You get the calcium carbonate, you require starch, and you get from there. Okay, and finally you have a different compounding area where you perform your practicals, and finally when you produce any product you store it in a different place. So here also you have a different layout of the aseptic area in which the production facility is divided into separate rooms. Okay, so let's see the layout of the aseptic area. So here you can see the aseptic area is divided into different sections. Okay, so first you have the office where the staff or the personnel are sitting, from where you can go into different areas. Okay, then you have a stock room. What is a stock room? As it is saying, something is stocked here. Okay, so what is stocked here? The raw materials, the different apparatus, everything is stocked here. Okay, now you see there is airlock. This indicates that each area is secured with an airlock. Okay, what is airlock? That we'll see in detail. Airlock means the doors are maintained under positive pressure. Okay, from the stock room, once you procure the raw materials and the apparatus, you have the cleanup area. Okay, in the cleanup area, the air is forced which will clean your apparatus, the raw materials, and also the personnel has to pass through forced air to remove any microbial or particulate contamination. Okay, for the raw materials, you have reverse laminar airflow facility. Okay, what is laminar airflow? It is the airflow in unidirection. But for the raw materials, you have a RAF, that is reverse laminar airflow, in which the air is passed in opposite direction. Laminar air is forced in opposite direction so that your raw materials are rendered free of any impurities. Okay, so from the cleanup area, finally you enter into the compounding area. Compounding area means the area where you perform any mixing operations. Okay, mixing of the ingredients take place in the compounding area. Now from the cleanup area, as you can see, you can directly enter into the sterilization area, or you have to go to the compounding area. Okay, this step, and from the compounding area also, from to and fro you enter to compounding area, from the sterilization area, or from the sterilization area to the compounding area. This depends whether the product is in process sterilized or it is sterilized at the end. Okay, if it is in process sterilized, then after the cleanup area, once you have procured the stock, it will directly go into the sterilization. Means here the raw materials and the apparatus like the ampules, wires which are required for parenterals are sterilized here, and then it goes to the compounding area. Okay, if it is to be end sterilized, then from the cleanup area, when you enter the compounding area first, where you mix the ingredients, and then finally the product goes to the sterilization area. There the product is end sterilized, means first the product is manufactured and then it is sterilized. Okay, so from the compounding area, it may enter into the aseptic filling area. Now aseptic filling area, it is a very important area, means the filling operations will take place in the aseptic area only. Okay, where the microbial and particulate contamination is very low. Okay, this the air conditions in the aseptic area are different from all other areas. Okay, so after the aseptic filling area, it may enter into the sterilization area, or vice versa, as we have talked about, whether the product is in process sterilized or it is sterilized at the end. Okay, so after the product is sterilized, finally sterilized, the sterile product is kept into the quarantine area. Quarantine means it is placed there for long period of time before it is packed and labeled. Okay, here the entry is totally restricted. Okay, by special permission only any person can enter into the quarantine area. From the quarantine area, finally the batches go for packaging and labeling, which is very important for the parenteral products. Okay, during packaging and labeling also the care should be taken that you avoid any microbial or particulate contamination. Finally the product goes for the quality control check. Okay, in this checking, the sterility testing is done to see how many microbes or any contamination is present or not, and finally it goes for the storage and shipping. Okay, this layout is very important from the exam point of view. Okay, and it's very easy to remember, but you have to take care of the arrows from where the person can enter into which area, and different layout in the order. Okay, the cleanup section. Okay, the clean area has the walls and ceilings which are made up of film coating materials. Okay, the air here should be free of dust particles and the microorganism, which is ensured through high efficiency, that is 95% high efficient filters. Okay, here the air is frequently replaced. Okay, it is frequently changed, that is you have 10 to 15 air changes per hour. Okay, the next section is the compounding section. As we discussed earlier, your actual compounding of the preparation takes place. For that, you have the stainless steel cabinets and the counters which are involved in the mixing operations. Okay, the very important thing to remember here is that the maintenance of sterile conditions is not at all essential here. But yes, you have to take necessary measures to prevent any dirt particles which are arising from the raw materials. Okay, the very important area is the aseptic area. Okay, as you see here, which I have highlighted, strict control measures should be adopted here. Okay, so the cabinet, the stainless steel cabinet and counters which are provided in the aseptic filling area where the filling operation takes place should be free of any microbial or dust contamination. Okay, the mixing and storage of compounded preparation should be done outside the aseptic area, where in the compounding area. Okay, you have already mixed the components and stored in the compounding area, but the actual filling operation will take place in the aseptic area. Okay, the quarantine section. Okay, this term is commonly you are hearing in this time. Okay, quarantine means you have to separate it from the other area. So here also the product are stored in the quarantine area. Okay, it is a store where the in process batches are stored, which as well as approved batches are stored in a different area. Okay, this area has limited access. Okay, and it is under supervision of a responsible person. Okay, and without any consent, no person can enter into this section, right? Then is the packaging and the labeling section. Okay, what is here done here? The products which are finished, the finished products are packed and labeled in this area. Okay, which is done by the packaging machines. Okay, only one product labels are printed at a time. Okay, the parenteral packaging, as we know, plays a very important role in the production of sterile products. Okay, so it should be done in a manner, the packaging and labeling should be done in a manner to prevent or to prevent any contamination, or you can say to preserve the sterility of the product. Okay, so here you see next is the clean area classification. Okay, how you classify the clean area. So normally the clean area are classified into four grades. You have grade A, grade B, grade C, and grade D. Okay, like you get the grades, okay, in which the A grade is counted always superior. So here also they are graded based on the microbial monitoring of the environmental air, the surfaces and the operators when the area is properly functioning. Okay, so how much microbial contamination is there in that area, based on that the areas are classified into A, B, C and D. Okay, so viable microorganism per meter cube of the air. Okay, what is viable microorganism? Viable means living organism per meter cube of air. Okay, so grade A, which is the superior area, has less than one viable microorganism per meter cube of air. Okay, then B, it has 10 microorganism, C 100 and D it has 200. Okay, the settle plate method, that is the settle plate 9 centimeter of the plates per 4 hours. Okay, that you keep the plates in that area and then the counting of microorganism is done in that plates. Okay, so here also you have the settle plate method A, B, C and D. Here in the A, grade A you have less than 1, grade B 5, grade C 50 and grade D 100. Okay, so normally the aseptic area you have grade C conditions. Okay, that is you have not more than 100 particle 100 microorganism per meter cube of air. Okay, that is counted standard. Okay, so let's begin with the building facilities within an aseptic area. Okay, so first one are the floors, walls and the ceilings of the aseptic area. Have you ever paid attention in your house or in the lab? How are the floors, walls and ceilings? No. But here you need to pay proper attention to the construction of the floors, walls and ceilings. Okay, so as you know that the floors, okay, the walls, okay, corners of the walls, the cracks in the walls are the major sources of accumulation of the microbial and dust particles. Okay, one ad you have seen for the mosquitoes. Okay, कोनों में ऐसा क्या है? Okay, but the person says क्या मैडम कोनों में ही तो छुपते हैं जानलेवा मच्छर. So here also the corners of the walls are the major areas where the microbial and the dust particles can accumulate. Okay, so the all clean surfaces including the floors, walls and the ceilings must be smooth. Okay, smooth means they should be devoid of any cracks. Okay, easy to clean. Okay, disinfected and should be constructed to minimize the microbial and particulate contamination. So normally you will see in the aseptic area that the walls, the corners of the walls are rounded. Okay, do not have this sharp construction. You have the rounded corners to prevent the contamination of by the microbes and the dust particles. Okay, the flexing and the non-flexing types of materials are used for the construction of the floor. Okay, the flexing floor materials are made up of the synthetic elastomers, of which the most commonly used are the PVC, that is polyvinyl chloride. The PVC flooring is easily repaired. That is the advantage, that is it is easily repairable, cleaned and it is relatively cheap and simple. Okay, the non-flexing floor are made up of hard inorganic filler substances in a matrix material. The walls must be non-inflammable, okay, which is very important because in the aseptic area, you are normally dealing with the flames, okay, the burners are normally there. So the walls should be non-inflammable, or they should be fire resistant materials. It should be made up of fire resistant materials such as the stainless steel, glass, animal steel, etc. Okay, so generally plaster walls are easily damaged by the impact. So you should avoid the plaster walls. Okay. Now for the reduction of the fungal growth, you can incorporate 1% of 8-hydroxyquinoline, pentachlorophenol, etc. to be added to the paint. Okay, the paint should be incorporated with this materials in order to avoid the fungal growth. Okay, epoxy resin paints and polyurethane paints are also used to avoid the cracking and the peeling. Okay, as we discussed earlier, that cracks are the sources where the dust particles or the microbial particles can accumulate. So we need to avoid any cracks or peeling of the walls. Okay, the ceilings are sealed to prevent the entry of any microbial contaminants. The internal fittings such as the cupboards, the drawers, the shelves and the equipment must be kept to minimum. Okay, in the aseptic area layout you will see that all these excess things are kept to minimum. Okay, next are the doors, windows, and the services. Okay, here also it is important how the doors are constructed, how are the windows and the services. Okay, the doors, as we have discussed earlier, you have seen the term airlock. Okay, so doors are normally such that you have a positive pressure. Okay, we have discussed in our first presentation what was positive pressure. Positive P, P for positive, P for pure. Okay, positive pressure means you have more pressure inside so that anything from inside can go outside but nothing from outside can come inside. Okay, so windows also normally here are only for illumination purpose, they are not for ventilation purpose. Okay, so they should be non-openable windows. So let's begin. So those windows should fit flush with the walls. Okay, they should not be loose, any opening should not be there to prevent any contamination. Okay, windows if required only are there, and they are solely for the illumination purpose and not for the ventilation, and they should be non-openable. Okay, the doors also should be fitted by maintaining positive pressure that we have discussed. Okay, the doors should be limited in number only where required at the entrance of each section as we discussed in the aseptic area. Okay, all pipes also should which are passing through the walls should be sealed. Okay, and should be flush fitted and easily cleaned. The gas cylinder should be excluded here, and all gases should be piped from outside area. Okay, the sinks and drains also should be excluded in areas where aseptic procedures are performed in the clean rooms. Okay, the light sources also wherever they are there in the clean rooms should be fitted with the ceilings to reduce the collection of dust and to avoid the disturbance of the airflow pattern within the room. Okay, non-essential switches which are there should be kept outside the aseptic area. Okay, they should switches also you see you are cleaning normally cleaning the switchboards. Okay, they are also the places where the dust particles can accumulate. Okay, so the switches should be outside the aseptic area. Okay, the personal and protective clothing which we have discussed earlier in much detail. Okay, here you can see the person who is properly gowned. Okay, you must be feeling tedious if you want to go for parenterals or parenterals industry, then you have to be trained to properly gown yourself. Okay, so you see here is properly gowned from head to toe. Okay, he is also wearing glasses, gloves. Okay, so you are completely covering yourselves to avoid any contamination due to yourself. Okay, so personnel selected to work on the preparation of parenteral products must be neat and reliable. Okay, operator borne contamination can be controlled by limiting the number of person operators in the clean room. Okay, so only the person who are properly or well trained in this area should be allowed to enter into the aseptic area, and the person entry should be limited. Okay, only as and when required. It is not there as you are working in your labs. Okay, only limited number of persons are allowed to avoid the contamination due to operators, and they should be trained for GMP practice. What is GMP? It is good manufacturing practice and the aseptic techniques. Okay, he should wear the sterile protective clothing including the headwear, the powder free rubber or plastic gloves, a non-fiber shedding face mask, and proper footwear. Okay. Now the cleaning and disinfection of the aseptic area. Okay, this is done regularly to remove microbial and particulate contamination. Okay, the cleaning agents are the alkaline detergents, the non-ionic and ionic surfactants. Okay, different types of disinfectants should be also employed in rotation to prevent development of resistant strain. So you have heard the resistant microorganism. Okay, as we have heard that many microorganisms are resistant to many antibiotics. Similarly, they also develop resistance to the disinfectants. Okay, so you should employ different disinfectants, which you will the theory about disinfectants you will study in the different section. Okay, so correlated here. So different disinfectants are employed in rotation to avoid the development of the resistant microbial strains. Okay, different concentration of the quaternary ammonium compounds are used. Sodium hypochlorite, ethanol, and formaldehyde solutions are used as disinfectants in the cleaning area. Cetrimide or chlorhexidine in 70% alcohol also suitable as skin disinfectants. Okay, so the cleaning and disinfection of the aseptic area is a very important part. The references in this section are the Aseptic Techniques USP Chapter 797 and the Pharmaceutical Microbiology by Chandrakant Kokare. So you have three FAQs, frequently asked questions from this section. Define aseptic area and draw neat and labeled aseptic area layout. Okay, so you must be thorough with the layout of the aseptic area. Draw the aseptic area layout and give the clean area classification. And third one, describe in detail the building, construction, and production facilities required within an aseptic area. Okay. So students, I hope you are clear with the layout of the aseptic area and the building facilities which are required in the aseptic area. Okay. So in the next section, we'll see about the testing procedures of the aseptic area in detail. Okay. So I hope you have enjoyed this session and you refer different books for detailed study of this presentation. Okay. Thank you all. Please do like, share, and subscribe our YouTube channel Pharma Ignite, and do not forget to press the bell icon to get the regular notifications so that you do not miss out any of the topics in this chapter. Thank you.